Hi everyone, thanks for joining us for this training webinar on appearance issues. This webinar is one of a series of webinars that we've put together that are designed to help train professional powder coaters on many different aspects of the powder coating business. As always, we know we have customers with a wide range of experience and interest, and we appreciate and we know we can't capture everything in one short webinar. Nor can we cover every combination of equipment, pre-treat or experience that might lead to an issue. But we'll try to run through some of the more common appearance issues that we see in the field regularly. As well as myself, and I'm Fiona Levin-Smith from IFS Coatings, we also have Jason Parton, also from IFS Coatings. He's one of our application engineering managers, and together we're going to take you through some of the common appearance issues and how to tackle them. So sadly, solving powder coating appearance issues is not an exact science. So first off, what do we class as appearance issues? Well, appearance issues are those immediately visible defects found after the powder has been cured. They come in all shapes and sizes, and in this presentation, we're going to cover the different types of defects, how they occur, and how to prevent them. So I guess that's a lot to get through, so let's get straight to it.
So for starters, let's start with a common one we see, a defect that we call blooming. So I'm sure everybody's seen blooming at some point in time. Blooming tends to look like a foggy or smoky look across the area of a part. It could be a small area of the part. It could be the whole part. But sometimes it'll even look like a powdery residue. We normally see blooming on dark colors, your blacks, dark blues, dark greens. That is normally where we will see blooming the most. And that's really because, you get on the light colors, you just don't see that smoky look. You just don't notice it. But, blooming is truly caused by cheap resin. And what happens is during the cure process, sometimes the oven temperature or the metal thickness or a cold spot in the oven, for some reason the metal does not continue to rise in temperature, and it gets held up in that 325 degree range, and we get this smoky residue that comes out of the coating, and then it doesn't go away as it moves on up to temperature. So there's a couple of ways to really fix that. Obviously, the proper way to fix that is to have a resin that will not bloom. With that said, having a resin that will not bloom will result in a higher priced product. The other way to fix that is make sure you have proper temperature in your oven. You do not have any cold spots in your oven, and make sure if you have thick metal that you're able to get it to temperature in a consistent manner, and that you don't hold it in that 300 to 325 degree range for very long. So with all that said, usually blooming will wipe off with a wet cloth, or sometimes just even a soft dry cloth, it'll wipe off. There are times when it gets that powdery look that you might not be able to get it off, but almost always it's a temperature related cheap resin issue.
All right, well, let's move on and quickly look at blushing. And we're not talking about the rosy cheeks variety here. So first things first, it's good to note that blushing with powder coating is very different to blushing that occurs with liquid coatings. Blushing is also sometimes called telegraphing, and basically it's when a substance pulls through the coating from the substrate, discoloring the finish. It can be pretty random. You might notice one spot where the coating looks perfectly fine, and then you'll have another area where there's blushing or telegraphing. It can be caused by a number of factors, the most common being improper or poor pretreatment. If you think about it, this makes sense. Anything on the surface, from the ink of a marker to the residue left behind from stickers and stamps, can telegraph through the coating, and then of course that makes the coating itself look bad. Another factor that can cause blushing is aluminum oxidation. So as you can imagine, preventing blushing is actually pretty simple. The key is to keep a close eye on pre-treat and make sure you clean and pre-treat the surface of whatever substrate you're using, removing all residue, everything like that. And if there are any marks like writing or anything like that still on any substrate after a pre-treat, you need to go in, you need to grind it down, and you need to pre-treat again. If you do have aluminum oxidation, you need to sand the oxidation away, plus plus then apply pre-treat again to the newly bared surface. However, if your pre-treat system uses zirconium, don't go mad with it. Otherwise, you might end up with flash rust, which that can cause blushing as well, ironically. So I guess it comes down to pre-treatment all the way.
Okay, next we're going to move on to picture framing. I'm sure everybody's seen picture framing to some degree. There's actually, to me, there's a couple of different kinds of picture framing. I think the most common you'll see if you have a flat type part, you will see thick film build around the edges. It's so noticeable that it looks like there is a frame around that edge, hence the name picture framing. It can be heavy orange peel in those areas. It can be almost a look of wanting to sag, but not really a sag, just kind of like it humps up a little bit on those edges. So there's a couple reasons for that. The first reason is probably most common is just too much film thickness. That can be caused for a couple of reasons. It can be you have too much voltage along with too much powder supply, and those edges will always build heavier than the center of the part. So you get that heavy edge build, you run it through the oven and cure, and you see a difference in the look around the outside edges. Another time that we see picture framing, if you have a product that has a lot of flow to it, we will see, if you have an area where you have holes punched in the part, you'll see where once it cures, it looks like the powder is wanting to move or almost sag around each of those holes or indentions or whatever. And a lot of times that's because of so much flow in the part, you get that little extra film build, and once it gets in the gel state, it wants to move away from that edge. We all know we have edge pull with powder coat. So that's probably the two most common ways of seeing it. One thing that might help, obviously, if you have a lot of heavy film build on the edges, my first recommendation would be to turn your KV down and turn your powder flow down. If you don't have enough film build everywhere else and you can't turn the powder flow down, then obviously turn the KV or even the microamps down, so you're not building so heavy in some of those easier to coat places. And then, another thing we see people do a lot of times is they make a rack, with what we would call a robber bar, basically a bar or a surface right behind those edges. So that excess powder, instead of building on that edge, some of that excess powder will go to that bar and keep it from building too heavy on the edges. So that's quite common for people that have, Class A surfaces that really can't afford to have any difference in look, and they run the same parts on a regular basis. They're able to build those racks with a robber bar in place and take out some of the instances of causing picture frame.
All right, let's move on to outgassing. So unfortunately, outgassing is well known to many coaters, especially those dealing with cast steel or cast aluminum. And it's an especially annoying issue because a coating with outgassing is really easy to spot. So what is it? Well, during the curing process, little pockets of moisture or contaminants rupture on the surface of the substrate and work their way through the baking coating. Cast steel or aluminum contain tiny pockets of moisture. So during the bake, those pockets literally rupture and outgas. The result looks like little volcanoes or something like that on the surface of the powder coating. The most common reason for this is something is happening with the surface of the substrate before coating. Most commonly, porosity below the surface of the substrate or oxidization on the surface. We all know that oxidization can kick off a whole host of issues. If you're working with hot dip galvanized or aluminum and it's left lying around or outside, it can easily begin to oxidize. The result's then going to be outgassing if the oxidization is not removed before coating. One easy way to deal with this problem is to put the part in the oven before applying any coating. Half an hour at about 450 degrees or just hotter than the curing temperature in the oven will cause the substrate to outgas. So doing this preemptively before applying a coating is the best and simplest way to prevent outgassing from destroying a finish. Or you can also choose, you can also choose an outgassing forgiving, which is usually better known as an OGF, formulation primer or powder. Both IFS coatings and our sister brand Polychem make OGF powders to help circumvent outgassing. And the last tip for outgassing, if your job shop uses hot dip galvanized and the substrate forms white rust, then you need to mechanically or chemically remove it. Otherwise, you're going to get outgassing. And it's really not possible to fix the issue once it occurs. So preventative measures are the way forward.
Yeah, and I think to that last little note there, just because you blast something or just because you mechanically remove some of that surface doesn't mean that it won't outgas. So to outgas, you have to bring that part above your curing temperature. You might need to blast as well, but to outgas, it is getting the part up to temperature so that that reaction occurs before you get a coating on it.
Yep.
So next, let's talk about fish eyes and craters. And again, very common. We see this in a lot of shops. We see this for a lot of different reasons. My definition of a fish eye is a defect on the part where the coating has moved, whether it be a small hole or a significant size hole. The coating has moved until you can see the substrate. And a crater would be where the coating has tried to move, but it didn't go all the way to substrate. So you might just see a dip or exactly what it's called a crater in the surface, but it does not go all the way to substrate. So a lot of things can cause fish eyes or craters. It's usually obviously some type of contaminant. We see all kinds of contaminants out in there. People use WD-40. People use aerosol spray cans for touch-up paint. We see grinding disc and sandpapers that have silicone type media on them that doesn't get blown off properly, or it gets used close to where you're coating a part and it gets carried over by the air onto your part as you're painting, and then it results in fish eyes or craters. We also see it. You can see it from your air supply or moisture in your air, oil in your air, anything in that airstream that you're applying powder with can also is a contaminant and can also cause fish eyes or craters. The best way to maintain those things is, not everybody can afford an environmental room, but the best way to maintain those things is not to bring those types of things into your coating area. No aerosol cans. Make sure you have oil separators and moisture separators and things like that on your airlines. Try not to do touch-up work and sanding the same place you're coating parts. And if you do, make sure you have a way to collect that dust or those airborne particles. So really, that's the best way to get rid of, to keep from having fish eyes and craters, is to do the work up front and not bring into your area those things that can cause fish eyes and craters.
Okay, moving on to colour and gloss issues. So what are they? Well, I guess the name speaks for itself, but either the colour is shifted from what it should look like, or the pigmentation is uneven on the coating. And there's a few factors that cause these issues. Over baking is a big one. If the powder is overbaked, white pigments, pale colors, warm colors, and also clears will all darken and yellow. Another factor could be the coating supplier trying to cut costs by removing some pigmentation from the powder. For example, creating an unnatural white pigment by replacing a percentage of the titanium dioxide with calcium carbonate, which is a filler. If this is a new problem with a product that you've ordered before, or you've asked for some value engineering to be done to the product, maybe talk to your powder supplier about any changes that might have been made. Find out what's going on. Sometimes it really does just come down to the product that you're using, not how you are using it. So what else can you do to avoid color and gloss issues? Well, be mindful of your film thickness and follow the TDS, the technical data sheets, those instructions to the letter. If the TDS states a 400 degrees peak metal temperature for 10 minutes, make sure the part is at 400 degrees for the required time, not just the air temperature. The part has to be at that temperature. The time in the oven is also important. Leaving it in for 30 minutes will cause visible issues, and not leaving it in enough will cause functional issues. One more thing that you can do, which is really helpful in any scenario, is have sample panels that you and the customer can see beforehand. So try out different film thicknesses on different colored substrates. For example, using a yellow on a dark substrate, that's going to be different than using a yellow on a light substrate. So showing the customer what the differences can be, showing them up front, can be really helpful. Inconsistencies in gloss are noticeable and really annoying. Gloss failure is often caused by overbaking the coating, which then causes the coat to dull in places or even take on a yellow tinge. It can also be caused by undercuring the powder, which can cause the gloss to be higher than it should be and can also even cause color changes. For example, a white might even start to look blue. Likewise, using incompatible products together will cause a reject. This can be caused by using two different products on the same machine without cleaning the machine properly in between applications. Keeping your coating glossy by ensuring that you clean your equipment thoroughly and are using products that have been designed to work together will obviously help with this.
Yeah, one of the biggest things we see is not good cleaning will cause your second product to be low in gloss, and we see that on a very consistent basis. So, all right, let's talk about pore flow and orange peel. So orange peel, anybody that's been in the powder coating business for any time understands what orange peel is. And it got its name because it literally looks like the surface of an orange. It's not completely smooth. It has some hills and valleys and you know, there are different levels of orange peel, and those different levels, you know, can tell you a few things that are going on. So first thing, some of the ways to control orange peel are to make sure you're spraying the right film thickness. You know, there are coatings that are designed to be sprayed at 1 mil. There are coatings designed to be sprayed at 2 to 3 mils. There are coatings that are designed to be sprayed at 3 to 5 mils. All those things will affect what that coating looks like. So if I'm normally spraying 2 to 3 mils and I spray it at 1.5 or 1 mil, we are going to see a very tight orange peel that is not going to be acceptable probably to most people. It'll almost be a dry look. If we spray that same product at 6 mils, we're going to see an extreme rough looking orange peel or large orange peel that is not going to be acceptable either. So make sure we are spraying at the required film build. You know, other things that can cause, if you have a poor ground with applying too much powder or trying to apply powder too quickly can result in KV rejection, which will come back out of the oven looking like orange peel. Same thing, gun to part distance. If you stick your gun in there close with too much KV and apply too much voltage, you're going to have KV rejection. Again, you're going to have orange peel. The rest of the part might look great, but the area where you get too close, or maybe the edges where it built a little too much film, all of that is going to have heavier orange peel and visibly be noticeable. Same thing goes for recoating. Basically, recoating parts is not having a good ground. You already have a coating there. You don't have the ability to accept as much charge. Therefore, if you throw the same amount of KV and powder at it, you're probably going to create orange peel. So a lot of people don't realize it, but just by reducing KV on a part as you're spraying it, you can usually reduce the amount of orange peel it has. So if I spray at 100 kV and get my gun close, it might be fairly rough in orange peel, even though the film build is correct. If I spray that same part at 60 kV and turn my microamps down, it might smooth out completely different at the same 2 to 3 mil film build. So even though people might have an acceptable part, KV can very much make a difference in the amount of orange peel on the part. And then also don't forget some powders are designed different than others. You know, a low cure powder that's going through an oven that doesn't have a lot of heat is going to probably produce more orange peel than a high flow product that you're curing at well over 400 degrees. Those products are going to flow better. So there are a lot of things that then come into account that can cause your orange peel to be acceptable or to be different across a part. So let's talk about sags a little bit too. Sags is usually more of an issue with liquid paints. With that said, there are times we do see sags in powder coatings as well. You know, usually what happens, it tends to be a film build issue where we get way too much powder on the part, and as everyone knows, as you cure a powder, there is a time in there where the powder actually becomes a liquid and flows before it starts cross-linking back up and stops that flow. So if you just have a way too much powder in an area, once that becomes in that liquid form, gravity will just cause it to shift and you will get that sag. We also see it with formulations that are meant to have a lot of flow. A lot of times urethanes, we always talk about how smooth they can be, and you see them more of an automotive type finish. Well, with that type finish, you also have a better chance of having a sag around a punched hole or a spot in the part where you might be a little heavy on film build, and that excess flow will cause it to be a sag. And then probably the most other common reason for sags is just the product itself gets caught in the oven in a odd temperature range there, and it doesn't begin to cross-link quick enough. Therefore, it stays in that flow stage too long. So if you're having a sag issue and it's not film build related, your best bet is to talk to your supplier and understand what the flow of that product should be. Make sure you have the right heat, the right amount of time, and things of that nature, and maybe that will go away.
So pinholing. Well, pinholing looks very similar to outgassing, but just on a smaller scale. It's probably best described as tiny, almost microscopic indentations on the coating. If the pinholing is really bad, it can even evolve to look like a large crater. The usual cause of pinholing is when incompatible products are used together. Basically, they act as contaminants to one another, and it shows. So this could be different chemistries. For example, going from a urethane to a polyester can cause pinholing. Different cure cycles. For example, low and high cure products. Or it could even be different manufacturers, different powder manufacturers. With this in mind, the easiest way to avoid pinholing is by keeping your equipment clean, and that includes hoses, hoppers, and guns. If you do large jobs but switch powder types often, maybe even having dedicated equipment for different colors or different products is a good idea as well. In some cases, if the pinholing is showing up in the oven, you can turn up the oven temperature and cure out the contaminants. Jason, have you got anything else to add on that one?
Yeah, I think the point of having sometimes needing dedicated equipment, there are times just even though you clean your equipment well and think you've done everything you can do, there are times products just have enough of some substance in there that it will pinhole the following product, and it could be just because it didn't clear it out of the oven as well. We have literally seen, where we tried to run a polyester in behind a urethane, and there was so much residue in that oven, it took hours before we could ever get a good part. So sometimes you just need to understand your products and understand that sometimes you're going to need some dedicated hoses or a dedicated gun or a dedicated hopper. The next thing we'll look at would be film thickness. Kind of touched on a little bit about film thickness in the orange peel comments a while ago, but we have a technical data sheet for every product that we make, and that technical data sheet will usually list where that product performs the best and looks the best. So it's not that you can't paint it at 1 mil or 3 mils or 5 mils. Its performance is best at a certain film build. So like I said earlier, if you do not put enough powder on there, you're going to see a very tight, rough looking result. Depending on the color, you will even see the substrate show through and have a wrong color, especially yellows, reds, oranges. They don't hide well in the first place. So if you're a little low on film build, you could potentially see a color issue with that. Too much film build. If you have your settings where you have too much powder coming out, you can get some people call them surges, some people call them gun spits, but that can be a small area, the size of a pencil head, or that can be an area the size of a quarter. Depends on how much surge comes out of the gun. And that's usually a result of somebody trying to apply a lot of powder quickly, but they don't have enough air in the process to carry that powder throughout the hose and all the way out to the gun. So it'll fall out in the hose until it builds up too much. Then all of a sudden that air will catch it, pick it up, and you'll get a surge out the end of the gun. Surges can also come from equipment not being cleaned properly. You could get buildup in that gun, and then once it breaks loose through the pump or through the gun or through the hose, it's obviously going to come out as a gun spit. So prevention, equipment maintenance, make sure pumps are clean, guns are clean, hoses are clean, blown out, checked on a daily basis to make sure everything is proper the way it should be. We haven't really talked about fluidizing. If you don't fluidize the powder properly, you will potentially get surges or gun spits. A lot of times people fluidize it too much. You get these air bubbles within your fluidizing hopper. As the pump picks it up, you'll get surges of powder coming through there, which will result in an uneven coating, sometimes too much, sometimes too little. If you don't fluidize powder enough, it will not carry through the hose properly. You will get that same gun surge where it'll fall out in the hose. Finally, you block that hose off, and the air will pick up that whole amount of powder and bring it all the way to the end of the gun, and you'll have a large deposit of powder. So make sure your gun settings are good. Make sure the patterning coming out of the end of the gun is a good, even patterning, and you're not blowing an excess amount of powder out as you're trying to coat.
All right. Thanks, Jason. Well, there we have it. Hopefully we've covered some of the more common appearance issues that occur and how to avoid them, which is the important stuff. And we also have a range of videos that will take you through some of the issues we've covered today. They're all online at ifscoatings.com. You can find them in the resources section. There's also information on these topics in our ebook and in our series of blogs, which are also on the website. And you can also find those videos on YouTube on the IFS coatings channel as well. So make sure you check out our other webinars, and these cover other topics that we're looking at, such as the different types of powder coating, application issues with powder, easy quality control, testing, and even powder coating equipment. If you do have any questions, then you can see the email address on the screen. Feel free to email in your questions, and Jason and some of the other members of our application engineering team will take a look at them and get back to you. And with that, we'll say thanks, and we'll see you next time.